Thank you. So, Sir Goldsworthy Gurney. I've come from the Castle Heritage Centre in Bude in Cornwall, and we have a link to Sir Goldsworthy Gurney, which I'll tell you about shortly. So Gurney was a man whose ideas were way ahead of his time. He was one of the great Cornish minds of the 19th century, and he pioneered new forms of heating, ventilation, lighting, signalling, firefighting, agriculture, music and architecture. He even sought to develop an aircraft engine. Sir Goldsworthy Gurney's achievements were remarkable, yet they remain largely unknown. Here's the man, a man of many talents throughout his life, including a doctor, a surgeon and an apothecary. He was a scientist and a university lecturer. He was an engineer, an architect and a builder. He was an agriculturalist and a farmer. He was a consultant to Parliament, and he was also an accomplished musician and pianist. He even invented a type of glass piano. So Gurney was born in Avon Cottage in a little village called Treetor near Padstow in Cornwall on Valentine's Day, the 14th of February 1793. He was born into a family that was considered as landed gentry. He was one of 6 siblings, and he was originally educated at home, as is the way with the gentry. He was given the name Goldsworthy in honour of his godmother, who was the daughter of General Goldsworthy, and she was maid of honour to Queen Charlotte, the wife of George III. At around age 7, in 1800, he went to Truro Grammar School, which at the time considered itself the equivalent of Eton. He spent 9 years at this school, boarding for 2 guineas a year, and he would have learnt Greek, Latin, Roman antiquities, writing, literature and religion, and music and French were also taught at an extra cost. And the school sent most pupils on to Oxford, mostly for religious training. However, in 1805, when Gurney was aged 12, a new headmaster was appointed, who brought in a lesson that was new to the education system at that time. This lesson was natural philosophy, or as we know it today, science. This new headmaster also introduced mathematics, geometry, navigation and astronomy. And Gurney left school in 1810 with interests in the tides, the movement of sands, weather conditions and farming practices. After leaving school, aged just 16, Gurney was apprenticed to a Dr. Avery in Weybridge, a practising physician and surgeon. Gurney also trained to become an apothecary, meaning he could dispense the medicines of the day to his patients. And when Gurney was aged only 20 in 1813, Dr. Avery retired and Gurney took over the practice. The following year, he met and married Elizabeth Simmons, who came from a farming family at Launcells in North Cornwall, not far from Bude. In January 1815, their daughter Anna Jane Gurney was born, and shortly after, Gurney started to become more interested in science and engineering. In 1820, he moved with his family to London, apparently discontented with rural life and wishing to seek his fortune. The family settled at 7 Argyle Street near Regent Street, where Gurney initially continued to practice as a surgeon. Once in London, Gurney expanded his scientific knowledge and started giving a series of lectures on the elements of chemical science to the Surrey Institution, an organisation devoted to scientific, literary and musical education and research, where he was appointed a lecturer in 1822. Chemist and physicist Michael Faraday, who was then assistant to Sir Humphrey Davy at the Royal Institution, admitted his indebtedness to these lectures by Gurney, which dealt chiefly with heat, electricity and gases, and also anticipated the principle of the electric telegraph. A son, John Goldsworthy John, was also born that same year in 1822. A skill that was attributed to Gurney was an ability to express scientific thought on paper and through his lectures. His lectures in 1822 to 23 included one on the application of steam power to road vehicles. More of that shortly. He was also of a practical bent, and in 1823 he was awarded this Isis Gold Medal of the Royal Society of Arts for devising an oxy-hydrogen blowpipe. This was an improved blowpipe, a device which safely burnt oxygen and hydrogen together, creating a very hot flame, for which he won some renown. Unlike its predecessors, Gurney's blowpipe was made of soft materials, a silk bladder, cork and wood, rather than the copper, and was therefore less dangerous in an explosion. The gases were contained in the bladder, which was slowly compressed by pressing or putting weights on the lower board. This is an example of one we can see in this photograph here. And as we will see, this was a device that he would adapt many times through his life for a variety of uses. In 1825, still in London, Gurney began to construct his own steam vehicle. He first tested a small locomotive powered by ammonia gas. The test was a success, and after successfully patenting the vehicle, Gurney established a workshop in London where he built his first full-size steam carriage. The following year, he leased this factory near Regent's Park to develop his steam carriage. Gurney's first patent in 1825 concerned a tubular steam boiler, as we can see in these designs that are held by the Science Museum. In 1826, using his oxy-hydrogen blowpipe as a basis, he created a similar device which became known as the steam jet or blast pipe, which would increase the flow of air through a steam engine's chimney, increasing the draw of air over the fire, and in short, much increasing the power to weight ratio of the steam engine. Gurney found that this could be used to increase the speed of his steam carriage. This was a breakthrough, and Gurney tested the steam jet on an improved carriage. In 1827, Gurney obtained a patent for a steam coach or carriage adapted to convey passengers and baggage and to be propelled forward on common roads by the power of the locomotive steam engine instead of horses. During 1827 and 1828, Gurney built several versions of his steam carriage and drove them frequently on public roads around London. The external appearance of the steam carriage represents that of the familiar coach, but without the horses. It was mounted on 4 load-bearing wheels with 2 small pilot wheels at the front by which the coachman could steer the carriage. The carriage ran on charcoal or coke and could carry 6 passengers inside and 15 on the outside. They were the cheaper tickets. As you can imagine, this created a lot of public interest with many illustrations and reports often seen in the national press. And here we can see a scale model, a scale reproduction of the 1828 steam carriage built by Gurney. This model represents the improved design built at his Albany Street manufactory, and this model is built to the scale of 1 inch to 1 foot. The actual length of the carriage was about 15 feet. And this model is on display at the Castle Heritage Centre in Bude. The carriage was powered by high pressure steam generated in a boiler mounted on the back part of the vehicle. However, the public was sceptical as to its safety, and some people were reluctant to travel on a vehicle where they had to sit over the boiler that they had heard was prone to explode. Reports told of one that had exploded in Scotland, as we can see here from this illustration from a newspaper at the time. And the photograph in the top left corner shows the chassis, the remains of the chassis of the exploded carriage that is now on display at the Riverside Museum in Glasgow. Gurney therefore set about separating the locomotive engine from the carriage, and by the winter of 1828 he had developed the Gurney drag. Gurney's drag became the world's first mechanised vehicle on road or rail to travel over a distance at a sustained speed. In 1829, Gurney was asked by the Prime Minister, the Duke of Wellington, for a demonstration of his steam drag. This was arranged to be at Hounslow Barracks on the 12th of August. The Duke was interested in using the drag to transport weapons and soldiers. The demonstration showed that on a good level road, the drag could achieve speeds of up to 20 miles an hour, with between 12 to 16 horsepower, and after drawing a carriage containing 27 men, it was estimated that it might draw 7 to 10 ton or 100 men. And here we can see a sketch of the time titled Mr. Gurney's New Steam Carriage as it appeared in Hounslow on the 12th of August, with a carriage attached containing the Duke of Wellington and other persons of distinction. After the demonstration, the Prime Minister decided the machine to be of great national importance and invited Gurney to further demonstrate the effectiveness of his drag by undertaking a journey from London to Bath and back. On the 27th of July, Gurney and his horse-drawn support vehicles left London for Bath. Within 1 mile, the drag had collided with the Bristol mail coach, and it had to continue the remainder of the journey with power to only 1 wheel. However, it did progress, and at 8 p.m. on the 28th of July, the drag reached Melksham near Bath, and there was a fair in progress, and the streets were crowded. Some stagecoach workers, on seeing Gurney's carriage, began agitating the crowd against this unhealthy and noisy form of transport. Abuse and then stones were hurled at the unfortunate passengers, 2 of whom were injured. Gurney was forced to place his vehicle under armed protection for the night and to proceed to Bath the following day with an escort. On the return journey, they went through Melksham at night using horses instead of steam so as not to wake the residents. According to Gurney's daughter Anna, unemployed mill workers and Luddites from Melksham set upon the carriage, burnt their fingers, threw stones and wounded poor Martin the stoker. Despite the mishaps, the journey had been a success, with the drag averaging 15 miles an hour. A stagecoach at the time would average 8 to 9 miles an hour. So it was quite an improvement. Orders for the steam drags flooded in. However, 2 months later, trials were held to find the most successful railway locomotive. These were called the Rainhill Trials. Gurney's steam drag was under threat from the railway. The Rainhill Trials was a competition that was run from the 6th to the 14th of October in 1829 to test an argument that locomotives have the best motive power. The winner of these Rainhill Trials, as I'm sure many of you know, was George Stephenson's rocket, which borrowed heavily from both the work of Richard Trevithick and Gurney. Richard Trevithick was another Cornish inventor, also involved in the Rainhill Trials, with his Catch Me Who Can. He had also experimented with steam carriages on the roads of Camborne with his Puffin Devil in 1801, which we can see a model of there on your right hand side. In his youth, Gurney had met Trevithick in Camborne, witnessed his early experiments with steam, and he had been inspired by him. As so often happens, many inventors working in the same field often borrow ideas from each other. But this meant that Gurney didn't always get the credit for his innovations, and other people working in similar fields became associated with the inventions that were in fact Gurney's. The steam jet or blast pipe, which served to increase the draw of air through the pipes, was applied to increase the efficiency of steam-powered engines and blast furnaces, and of road and rail vehicles. After the Rainhill Trials of 1829, there was considerable controversy as to the genesis of this invention, since it became associated in the mind of the public with George Stephenson, probably also through the agency of Samuel Smiles' biography of Stephenson. Others tried to debunk claims for this being Gurney's invention by comparing the output of Gurney's carriages with those of Trevithick, and yet another book that we can see here laid the steam jet invention firmly at the feet of Trevithick. In this book about the life of Trevithick, albeit by a family relation, Francis Trevithick, it states it was Trevithick's high pressure that enabled the steam engine to be used for such purposes. Gurney's daughter, Anna Jane, has annotated her own beliefs into this book about her father's invention, and she has written in here, it was the blast produced by Gurney's steam jet that enabled Stephenson to win the prize. The steam jet had given high speed on common roads, and this was its first application, viz. In 1829, to a railway carriage, i.e. locomotive. Gurney continued growing his steam drag business, and by 1831, several companies were operating steam drags across the country. Sir Charles Webb Dance, a British Army officer during the Napoleonic Wars, had witnessed a steam drag demonstration at Hounslow Barracks, and he became an enthusiastic motorist and did a great deal to encourage engineers who were engaged in the invention and development of steam road vehicles. He backed Gurney and ran a Gurney steam coach from Gloucester to Cheltenham 5 times a day for 4 months. Around 3,000 passengers covered some 4,000 miles in that time in Gurney carriages. However, the horseless steam drag was unpopular with the horse coach proprietors and horse feed producers, as well as mail coach companies who could not match the speed of the drag, and they were losing business. Gurney's steam drags had to be run on public roads and were increasingly the target of sabotage. For example, large stones or long tracks of gravel were put in the road to stop the steam carriage's progress. And as the government invested more in rail locomotives, the increasing number of steam carriages provoked adverse legislation, and a large number of turnpike bills were put through by Parliament imposing prohibitive tolls on carriages worked by machinery. Such acts forced the abandonment of the Cheltenham to Gloucester service in 1831. As mentioned, a drag in Scotland had blown up, but this was also possibly as a result of sabotage. However, orders for the steam drag ran dry, and in 1832, Gurney was forced to auction off everything. His losses amounted to £232,000, £8 million in today's money. This is when Gurney left London and returned to Cornwall. He moved his family to Bude and built his castle. The castle itself was also an experiment. He chose 2 acres of sand dune belonging to Sir Thomas Dyke Ackland, selecting the location to demonstrate that a sizable building could be constructed on sand if the correct foundations were laid. Gurney overcoming the problem of building on sand by constructing a concrete raft made from Roman cement. People said to him, "You cannot build a large structure on sand." Gurney said, "Wait and see." He took his inspiration from Kivartha Castle in Merthyr Tydfil, that we can see here, which was designed and built in 1824 to 25 by William Crawshay near his ironworks at Merthyr Tydfil, where sometime between 1825 and 1830, Gurney had visited and delivered and tested a steam locomotive to work in the ironworks. The great stone walls and crenellated castle towers of Crawshay's mansion had so impressed Gurney that he decided to replicate them on a reduced scale in his own building. The design of Gurney's castle also drew inspiration from the Romantic movement of the early 19th century. Here is a picture of what the castle that Gurney built would have originally looked like. Gurney's original building was smaller than the current day castle. He designed and built the castle in 1830. It took 2 years to build, being completed in 1832. There's no plans remaining of the original castle or how he built the foundation, but we think there were central corridors running through the castle with rooms off either side. All the plans were lost during World War II in a fire in a solicitor's. They were all held in a solicitor's in Exeter that was firebombed during World War II. So sadly we lost everything. The castle was extended, as we can see here. We can see Gurney's original castle in the centre, and it was extended on either end by the following leaseholder, Reverend William Maskell, who took on the lease of the castle from 1859. And this is how we see the castle still today, with the extensions that he had added to each end. They said to Gurney it would be impossible to build on sand. Gurney said, "Wait and see." And here we are nearly 200 years later, the anniversary approaching in 2030. Gurney's method of building a large structure on concrete without deep foundations is still in use today. As mentioned, Gurney had invented the oxyhydrogen blowpipe, which safely created a very hot flame. The invention winning Gurney the Royal Society's Gold Isis Medal in 1823, and also, as I said, adapted to help to increase the speed of his steam engines. Well, once Gurney was living at the castle became his laboratory, and he continued his experiments. Using his oxyhydrogen blowpipe, he found that when calcium oxide, or lime, was introduced into the flame, a very bright light was produced. Gurney named his new bright light the Bude Light. It is said that Gurney managed to light all the rooms in the castle using just one Bude light and an ingenious set of mirrors and lenses to direct the light into different rooms that came off the central corridors. Gurney's daughter Anna Jane was his constant companion, assisting with his experiments and attending to his paperwork. Theatres began to use the oxyhydrogen light with lime. As it was very bright, it was often used as a spotlight. Here we can see an example of an 1860s spotlight on the left-hand side. And this is where we get the phrase, in the limelight. Spotlights are still known as limes in the industry today. However, despite Gurney's best efforts to provide lighting and heating at the castle, Gurney's wife Elizabeth never found the building very comfortable, and it is said that she was unwell and not very happy living in the isolated castle, surrounded by the sea at high tide and right next to the noisy industrial wharf area of the canal. In 1837, she sadly died. Following her death, Gurney soon moved out of the castle and went to live in a house called Reed's in Poffel, a little village on the outskirts of Bude. Now in 1834, the Houses of Parliament, the Palace of Westminster, burnt down and was largely destroyed. Ministers invited Gurney to find a way to safely light the House of Commons, and in 1839, Gurney installed 3 Bude lights into the ceiling of the Commons chamber, which replaced 280 candles. In 1853, the rest of Parliament was fitted with the Bude lights, which remained in place for over 60 years, only being replaced with the advent of electric lighting in around 1913. In 1845, Gurney also used his Bude light to create a form of street lighting. These lights were used around the streets of London, including on Pall Mall, Trafalgar Square and Westminster Bridge. This slide shows an illustration of a Bude light in Trafalgar Square installed in 1845. Excuse me. And a photograph of the same light that is still in Trafalgar Square today. And this is the same light that I have the model of over there. The light in the photograph is in the southeast corner of Trafalgar Square, and in 1926 the concrete plinth was hollowed out, given narrow windows and a door, and was turned into possibly the world's smallest police station. It had a telephone inside it with a direct line to Scotland Yard, and also contained 2 holding cells. The light would flash when the phone to Scotland Yard was in use to alert any police in the area that trouble was afoot. These Bude lights are still standing in London. These photographs show the police station light that is now used as a Westminster Council cleaning cupboard. And here, one of another light in Trafalgar Square that has the more common lamppost stand. This is just like the ones that would have been along Pall Mall and across Westminster Bridge. Gurney continued to innovate with his experiments in light. Early lighthouses were painted different colours to help distinguish between them. However, this didn't work so well at night. So something had to be done to help sailors to identify where they were. In 1834, a parliamentary committee was set up to reform Britain's lighthouses. Gurney wrote to the committee, pointing out his earlier experiments with the oxyhydrogen blowpipe to produce a bright flame. The committee enthusiastically hired him to make improvements. This model we see here is based on the patent application submitted by Gurney and Frederick Rickson, an experienced brass lamp manufacturer in around 1839. The argand oil lamp was the most commonly used in lighthouses, and Gurney discovered that if a stream of oxygen was directed into the flame of a standard argand lamp, the brightness was increased greatly. Gurney further enhanced the effect by introducing a curved metal reflector. Finally, Gurney realised that if each lighthouse had its own individual flashing sequence, this would mean much improved navigation for seamen. So he incorporated a mechanism to rotate the reflector, allowing it to create the flashing light. This simple but effective idea is still in use today. And so it was that from the mid-1830s, Gurney became well known in Parliament, and he was consulted on a variety of matters by the ministers. Here we see his own parliamentary red box, and these keys were also found amongst Gurney's personal effects in an envelope marked "Keys belonging to the Houses of Parliament." Well, I don't know whether they still work, but he obviously had the freedom of the house with his own set of keys. Gurney was then asked by Parliament to investigate ways of preventing explosions in mines. During the 19th century, mines were very dangerous places. In June 1835, 101 men and boys were killed in an explosion at Wallsend Colliery in Newcastle-on-Tyne. Parliament asked, could Gurney help prevent such an accident happening again? Gurney once again proposed to use his steam jet, this time connected to a furnace to blow air through the shafts, clearing them of the explosive gases which may have built up. The investigating committee recommended the steam jet to mine owners, but the idea was treated with scepticism. In 1849, though, Gurney was asked to help extinguish a fire in a coal mine near Manchester. This time he reversed the principle of his steam jet and blasted mine gases into the shafts, suffocating the flames. The following year, he applied the same principle to fighting a fire in a colliery at Clackmannan in Scotland. This fire had been burning in the mine for 30 years and covered an area of 105,000 square metres. Gurney extinguished the fire, saving an estimated £200,000 worth of property, £17.5 million today. As a result of evidence given by Gurney, the government enacted that all coal mines should have 2 shafts, as we can see here. In the Victorian era, raw sewage flooded into the River Thames and caused outbreaks of cholera, from which thousands died. From 1854 to 1863, Gurney was the superintendent of lighting, heating and ventilation for the House of Commons. As Inspector of Ventilation, Gurney was asked to improve Parliament's foul-smelling sewers. Initially, in 1851, Gurney was asked to give evidence at a parliamentary committee about the possibility of ventilating the House of Commons. Gurney set about conducting investigations and experiments, again using his steam jet furnace system. Gurney recommended that air intake from the building should be a low level to avoid dragging in smoke from neighbouring chimneys, and he also proposed that the foul air be expelled through the clock tower, the Elizabeth Tower as it's now known, which houses the Bell Big Ben. In a successful experiment, he made all the sewers in the area airtight, introduced his steam jet furnace and connected a pipe carrying the noxious gases to a ventilation system in the clock tower. Parliament also asked Gurney to address the smell coming from the River Thames. He proposed that the Thames be dredged and contoured to ensure a fast and steady flow of water to wash away sewage. He also recommended that sewage pipes emptying into the Thames should be below the waterline to prevent foul odours. Gurney presented his findings to Parliament, but discovered that the Metropolitan Board of Works had proposed alternative plans for the Thames. Gurney believed that the chief engineer of the MBW had purposely sabotaged his system during the testing for his own gains. Yet again, Gurney's solution was overlooked. Gurney was also asked to investigate the possibility of heating Parliament. For this, he proposed a warming battery consisting of zinc plates attached at right angles to iron tubes. Gurney installed the new ventilation and heating equipment in 1855. His system stood the test of time and only needed minor alterations in subsequent years. In 1856, Gurney patented his Gurney stove as certain improvements in warming and moistening air. The apparatus was described as a metallic vessel having a number of plates extending from its outer surface, standing with the plates vertical in a shallow trough of water. This was significant in attempting to provide humidification to offset the drying feeling caused by warm air. Gurney sold the rights to his patent stove to the London Warming and Ventilating Company, which advertised itself as proprietors of the Gurney stove and remained active until the 1950s. The Gurney stove was made in three sizes, the largest being 2.7 metres in height with a 1 metre diameter, sitting in a 1.8 metre diameter base, and was said to be capable of heating a space of 120,000 feet cubed. Now, anyone who's been in the cathedral may dispute that. They sold well for many years and became Gurney's most successful venture, his most commercially successful venture. The stove's most interesting feature being the use of the external ribs to increase the surface area of the stove available for the heat transfer, the forerunner of the modern radiator. They were extensively used to heat a wide variety of large buildings, and by 1897, the London Warming and Ventilating Company claimed over 10,000 churches, schools, government, and other public and private buildings had been successfully warmed by their system. This included 22 cathedrals, such as Durham, Exeter, Gloucester, Lincoln, Salisbury, and even St Paul's. Here you can see photos of some that are still in situ. You may recognise some of those. Some have been kept as exhibition pieces, whilst a few have been converted to run on gas, and working examples can still be seen at Tewkesbury Abbey, Hereford and Chester cathedrals, and of course here at Ely. A small Gurney stove was even taken to the Antarctic by Captain Scott. On a gently sloping beach on Ross Island, with the slopes of the active volcano Mount Erebus towering behind, a simple wooden structure has weathered the storms of Antarctica for over 100 years. Built for Captain Robert Falcon Scott to shelter his British Antarctic expedition team of 1910 to 1913, whilst they carried out sledging journeys of science and exploration. The 50-foot long building, often known as Scott's Hut, housed 25 men with an adjoining stable for the ponies and mules. With winter temperatures ranging down as low as minus 45 degrees centigrade, an insulated and heated hut was essential for survival. The building had 3 stoves, a galley cooking stove in the mess deck, a small heating stove in the stables, and it had this Gurney stove in the officers' wardroom area. And on this one you can see the adaptation of a water tank used for melting ice blocks to get drinking water. The silver part on the top. From school age, Gurney had also been interested in farming practices, and in 1844 he had purchased Hornicott Manor near Boyton, about 10 miles outside Bude on the canal. He built a cottage called Woodley Cottage where he lived for parts of the year. During this period, Gurney was president of the Launceston Agricultural Society and was an active farmer involved in farming in Cornwall for many years. Sadly, around this time in 1847, his son, John Goldsworthy, died, aged only 25. In 1854, possibly through his farming connections, Gurney remarried to Jane Betty, the daughter of a sheep farmer from Devon. He was 61, she was 24. They moved to London, and evidence in this 1861 census suggests that they had a daughter, Bessie Gurney, born in Chelsea. However, the marriage didn't work out, possibly because his new wife was younger than his daughter Anna, who was aged 39 at the time, and it is also thought that Anna Jane didn't approve of the marriage. Although they never divorced, they separated. Gurney returned to Bude, and Jane Betty and Bessie later relocated to Exeter. In 1863, Gurney was knighted by Queen Victoria for his public service to Parliament and to the country, and in recognition of his discoveries. Here we can see Gurney's death certificate, and we can see that on his occupation it is marked as knight.
Oh, yes.
3 months after receiving his knighthood, Gurney suffered a stroke, which partly paralysed him. He gave up the work he was doing for the government, and he retired to his house, Reeds, at Poffel, a little village on the outskirts of Bude. He lived there with his daughter Anna Jane, and she cared for him for a further 12 years until he died on the 28th of February 1875. Towards the end of Gurney's life, Anna sought to ensure that he was properly compensated for his government work, and after his death she strove to ensure that the credit for his inventions was not taken by others. As we saw earlier, there was Anna's copy of the Life of Richard Trevithick, where Anna appears to have purchased the book while living at Reeds in 1879 when she was aged 64, and within the book can be found her handwritten notes correcting many passages, the one we saw earlier being just one example. Here she is. Dale H. Porter, biographer and writer of The Life and Times of Sir Goldsworthy Gurney, wrote in 1998 that Anna was no shrinking violet. She had witnessed her father's chemical and steam experiments as a child. She had become his hostess, secretary, and no doubt laboratory assistant at the castle. She was convinced of her father's genius and determined that the public should not forget him. In 1880, she gave £500 in his memory towards the building of the new cathedral in Truro. She donated a gift of this chiming clock for Poffel Church in 1889 that we see in this photograph, along with the plaque that is inside the church, which reads, "His inventions and discoveries in steam and electricity rendered transport by land and sea so rapid that it became necessary for all England to keep uniform clock time." She also commissioned and designed a window for St Margaret's Church in Westminster. This was unveiled by the 3rd Duke of Wellington, grandson of the first one who took a ride in the drag. And the ceremony was attended by many Gurney family members, but sadly Anna Jane could not attend herself due to her old age at this time. Unfortunately, Gurney didn't have much luck during World War II, despite having passed away many years earlier. St Margaret's was also bombed and 2 windows were blown out, one of which was the Gurney window. We know it had depicted all his inventions, but unfortunately no photograph or drawing of it survives. We only have the inscription, "To the glory of God and in memory of Sir Goldsworthy Gurney, born February the 14th, 1793, died February 28th, 1875. He originated the electric telegraph, high-speed locomotion and flashing light signalling. He invented the steam jet and the oxyhydrogen blowpipe. He resided in Cornwall but spent much of his time in this parish, Westminster, chiefly at the Houses of Parliament. His wife Elizabeth lies at the church of the adjoining parish of St Martin in the Fields. This window was given by their devoted daughter, Anna Jane Gurney." Gurney himself was buried in St Swithin's churchyard in Launcells, another village just outside Stratton near Bude, and here you can see the church and Gurney's tomb. The tomb lies just to the right of the entranceway to the church there. The inscription reads, "To his inventive genius, the world is indebted for the high speed of the locomotive, without which railways could not have succeeded and would never have been made." Lady Gurney, Goldsworthy's second wife, died in 1911. She was also buried in Launcells churchyard, very near to Sir Goldsworthy, just a few feet away, as we can see in the 3rd photograph here. This is Gurney's tomb at the bottom, and just across the path we can see the top of Lady Gurney's headstone there. Her headstone reads, "To the dear memory of Jane Lady Gurney, second wife and widow of Sir Goldsworthy Gurney, born 24th of February 1830, died 11th of December 1911. My grace is sufficient for thee." To whom did thee refer? God or Gurney? We shall never know. So how much do we owe to Sir Goldsworthy Gurney? The pioneer of locomotion by motors on our roads, the salvation of many lives by the ventilation of coal mines. He invented the system of heating mansions by hot water, the flashlight for lighthouses, the steam blast revolutionising locomotion by steam, and he showed that houses could be built on concrete foundations, and he discovered the limelight and the oxyhydrogen blowpipe. So here you could say we have a man who invented the blowtorch, early central heating, air conditioning, and the precursor of the motor car. He even tried to invent an aircraft engine. Surely a man ahead of his time. Do you think he was a genius? Because I do. Thank you for your time.
Matt, thank you very much. Indeed, that's absolutely. And we thought that it's the week of the 150th anniversary of his death, so what a good time to have a lecture and to recall this extraordinary man. Thank you for that tremendous lecture as well. 17 people joining us online as well, which is even nicer. The video will be available because I want to see it again. There's a lot of information there. Matt very bravely has said that he'll take questions. No questions, that's fine. That's fine.
Yeah.
Not so much a question as a comment. I was delighted to see Scott's hut.
Yes.
My uncle was with Scott on that expedition.
Wow.
He was on the winter journey, and having come back after 6 weeks with temperatures down to -60 and below, boy, would he have been pleased to see that stove.
Who was that? Your
Absolutely cherry Garrett, my uncle.
Your uncle?
Yeah.
Wow, brilliant.
So that stove would have meant a heck of a lot to him.
Yeah, I'm sure they would have crowded round it of an evening. Yeah. Yeah?
As a good Cornishman,
Not originally. or do you mean Sir Goldsworthy?
the Goldsworthy,
Right.
as a good Cornishman,
Yeah.
he seemed to have done everything but work in hard rock mining, the Cornish speciality. Did he do much for the Cornish mines?
No, not that I haven't come across anything like that. The only thing was the preventing the fires in mines. Yeah.
Which is for coal, that's
No.
not a problem in hard rock.
No. So no, I've not. I had never come across any information about him with Cornish mining. No. No.
What evidence is there that Gurney invented the blast pipe used in a steam engine when many people in Cornwall will tell you that it was Captain Dick, Richard Trevithick?
Yeah. Yeah, well, like I say, they were both working in the same area and borrowing ideas. There isn't any conclusive evidence anyway, either way, who definitely did it. But there's talk of Trevithick had sort of started the process, if you like, and then Gurney maybe picked it up and sort of improved it. Yeah, but yeah, there's no, like I say, if you read the books about Trevithick, it will lay the steam jet as his invention. And also, as I said, a lot of people see it as George Stephenson's invention as well. But yeah, Trevithick was the one. Trevithick was working earlier than Gurney. Yeah, so the Puffin Devil that we saw was 1801, whereas Gurney's first carriage was not until 1825. So, but it was the oxy-hydrogen blowpipe that he invented that was adapted into the steam jet. So that's where the idea that it was Gurney's invention comes from, because he adapted it from that oxy-hydrogen blowpipe, which was his invention. Does that answer your question?
Where did you get the hydrogen from? Was it generated in situ?
I couldn't tell you. I don't know where they got their chemicals from in those days. So I can't answer that one, I'm afraid.
You said you had an experience today you've never had before. Tell us about that.
Oh yeah, so I've seen Gurney Stoves, but today I actually stood next to one that was emitting heat, and it was quite an experience actually, because at the Heritage Centre in the castle in Bude, I often lean on our Gurney stove, and there isn't any heat. So it was quite strange actually to stand next to one and actually warm up. Yeah, it was lovely. Yeah.
Didn't he also invent the stretchers?
No.
That wasn't him.
No, there's no link to the Gurney stretchers. No, we think that came from there was a cab company in America that was and it was there was a Gurney coach as well. It was to do with a coach, but it wasn't the same Gurney, I'm afraid. Yeah.
Not a question, but we actually visited the museum.
Oh, good.
And it was wonderful to walk in and see this beautifully painted Gurney Stove.
Yeah. Yeah. It was, did you enjoy the rest of the museum?
Yes, we did.
Yeah.
We went in 2 or 3 times.
Oh, good.
Yeah.
And did you ever play on all the interactives in the Gurney room?
Some of them.
Yeah.
You did more than I did.
Yeah. But yeah, I suppose, yeah, ours does look quite nice, nicely painted, but our one is, like I say, it's not in use. So, yeah, ours is a bit more,
Museum piece.
yeah, a museum piece. Yeah. Yes, sir.
Did his family have any connection with the Norfolk Gurneys, who were bankers, and in fact referred to by in one of the comic operas that we're so familiar with, as referring to someone as being as rich as a Gurney?
Right, well, again, I can't answer that directly, but I know the Gurney... Sorry?
It's Gilbert, sorry.
Right. I don't know if they had any links, but like the Gurney name originally came across with Norman the Conqueror, William the Conqueror and the Normans. Norman the Conqueror. There's a new one, isn't it? So I'd imagine there'll be some links somewhere, yeah. But I don't know for definite. You lot have got some hard questions. Yes, madam?
Did the glass piano ever get built, and what did it sound like? For goodness sake.
Well, again, we lost everything. Everything that all Gurney's plans and papers were all held in a solicitor's in Exeter, and we lost everything.
I just wondered whether it was more than a concept.
I think they did. No, they did make it. It was. They performed on it in London. I did read this the other week. At one of the exhibition places or something. It was played. Yeah. I don't think it was like a piano as we imagine it, but it was that idea of playing the glass to get the different notes. But yeah, if you Google it, you can find, it does say about, there was a performance in London. I can't remember exactly where it was off the top of my head. But yeah, or other search engines are available as well. But yeah, anybody else? Yeah?
Something. It might be interesting, we've done a lot of work on the Gurneys as part of our Net Zero
Yeah.
project, including quite a lot of thermal imaging work.
Right.
And quite a lot of analysis of the performance.
Yeah.
And they are actually quite efficient.
Oh,
I
right.
mean, the current ones have been out for about 32 kilowatt. And we can see from the thermal imaging, they're effective over about a 3-4 metre radius. Perhaps a little bit more of that. You certainly can tell when one of them goes down, it is actually quite noticeable.
Right.
And they're actually a perfect example of thin tube heat transfer. And I've actually used one for university exam, make a university exam question out of them. You make the theory perfect.
Brilliant. And so, I don't know, do you know how many cubic feet the cathedral is?
Lots.
Because you've got...
cubic meters somewhere, but I can't remember.
Because there's 7, I think, in there. There's 7 in there.
Yeah, we've only got 5 operations.
5 operations. Right. So, but you think they are quite efficient?
Yeah, they are actually quite efficient, yes.
Yeah.
The surface temperature is just under about 200. The fin tip's about 180, but the fin root is, because they're not quite symmetric across the position of the burner, but we have measured temperatures up to 200.
Right.
But I can still remember, I've only seen the solid fuel fired ones once, and that was in Tewkesbury Abbey a very long time ago. And there they used to glow a dull red.
46,000 square feet. Maths. So, do you think, and how much are they efficient in how much gas they use? now that they're gas?
They do consume rather a lot of gas. The 32 kilowatt is actually the input, it's not the output. 32 kilowatt is actually the output. Obviously, they also, of course, give out heat all the way at the stack. We've got a stack temperature of around about 130, 140.
Right.
So they're continuing to give out heat from the stack. I don't know. I mean, it's very hard because of the design to estimate their actual thermal efficiency, but they're not bad at all. We'd be sorry to see them go, but
Yeah.
it just doesn't seem at the moment to be anywhere decarbonised. And we have looked at ideas, including one which would actually involve running them on hydrogen, but that thermodynamic.
All right. That's why you wanted to know where he got the hydrogen from. Anybody else before we wrap up? Brilliant. All right, well, thanks for your time. Thanks for listening. You've been a good audience. And hopefully I'll come to Ely again.